No matter the distraction, I want you to watch this video till the end, because at the end of this video, even if you did not learn anything, you will know the meaning of homologous series. Welcome to Mathematics and Science Meal. Today on Mathematics and Science Meal, we'll be taking a meal from the subject chemistry, and the topic is organic chemistry, part 4. Yeah, that's where we are now. We have looked at part 1, part 2, part 3, and now we are on part 4. Make sure that you watch the previous videos so that you can follow us properly in this edition. Okay, today on organic chemistry, we'll be looking at basic terms in organic chemistry. Just relax as we take this meal together. There are several terms that are associated with organic chemistry, but in this particular video, our interest will be on homologous series. So let's look at the first part of the basic terms used in organic chemistry, and that will be homologous series. So number 1 term used in organic chemistry is what we call homologous series. Homologous series. So what do we mean by homologous series? Maybe you have heard about it before, or maybe you have not. So since it is a term, we need to define it. Yeah, we need to define it, and by the time we begin to look at the characteristics of homologous series, we will now explain homologous series further. So homologous series is a family of organic compounds in which a member differs from a preceding member by a methylene group. So a family of organic compounds in which a member differs from what? A preceding member or a successive member by what? A methylene what? A methylene group. And the methylene group is CH2. CH2, that's methylene group. So any group of organic compounds in which a member will differ from another member by this group, that group is said to be what? A homologous what? Series. So that family is said to be what? Homologous series. So examples. What are the examples? Examples of homologous series. Remember, I said that by the time we start looking at the characteristics of homologous series, we are going to explain this further, because I know you are wondering, this methylene group, do we have organic compounds that will differ from the preceding compound by a methylene group? Yes, we have. We are going to see that. So just calm down. Don't worry so much about the methylene group. CH2, that's the group we call what? Methylene group in organic chemistry. At least that's another thing you just learned now. So CH2 is methylene group. So you have that in your mind, but don't use it to insult people. Before you go about telling someone your ear looks like methylene group, don't use that to insult people. Alright, so what are the examples of what? Homologous series. We have alkanes. We have alkenes. These are various homologous series. We have alkynes. We have haloalkanes. We have ethers. We have alkanols. We have the alkanal. That's the one we call the aldehyde. Then we have the alkanones. That's the ketones. Then we have the carboxylic acid. Carboxylic acid. Or the alkanoic acid, carboxylic or alkanoic acid. We have the esters, which you also call the alkanoids. and so on. We have the amides. We also have the amide, right? We have the nitrides. So all these are what are different what homologous series. And in organic chemistry, we are expected to study them one after the other. You pick alkanes. You look at alkane, look at the nomenclature, look at the preparation, look at the physical properties, the chemical properties, look at the test and also the uses. You do the same thing for alkene, look at the nomenclature, the physical properties and chemical properties, that's the reactions, look at the method of preparation, look at the uses, look at the test, and you move to alkynes, the same way to haloalkanes and so on. Yeah, you look at all of them. So these are the homologous series. Now, each member in a given homologous series is known as a homologue. So each member in a given homologous series is known as a homologue. What do we mean by that? For example, in the homologous series alkane, the first member is methane, the next member is what? Ethane, and the next one is what? Propane, and so on. So each of them, we refer to them as what? A homologue. So this is a homologue, a homologue, a homologue. But all of them now gives us the word homologous series. So combination of these homologues will now give us homologous word series. So every member in a given, remember alkane is an example of homologous series. So all the members in alkane are all, each of them is what? A homologue. Each of them is a homologue. All right, what are the properties or characteristics of homologous series? What are the properties or characteristics of homologous series? So, characteristics of homologous series. Characteristics of homologous series. Number one, they have the same general molecular formula. They have the same general molecular formula. They have the same general molecular formula. So all the members in a given homologous series must have the same general formula. For example, alkane. The general formula of alkane is CnH2n plus what? 2. That's the general formula for alkane. For alkane. And all the compounds in alkane, all the homologues in alkane, all the members of alkane homologous series, they are all derived from this general molecular formula. Of course, N is the number of carbon. So when N is 1, we are going to have C1, so because we will not put down 1 as a substitute from your basic knowledge of chemistry. So if you put 1 here, 2 times 1 is 2, 2 plus 2, 4, so you have CH4. That's the first member we call what? Methane. Methane, the first member of the alkane family. So when NO is 2, if NO now is 2, so let's put that here, NO is equal to 1. If NO is equal to 2, what are we going to have? If you put 2 here, we're going to have C2. Then put 2 here, 2 times 2, 4. 4 plus 2 will give me what? 6. That's how we obtain the what? The next member, which is what? Ethane. So all the members in the alkane homologous series, they were all formed from this general formula, showing that the general formula of methane is the same thing as the general formula of what? For ethane. The same for what? Propane. So if you want to form any alkane, this is the what? The general formula of what? Of the alkane. So that proves that in any homologous series, the first characteristic is that they have the same general molecular word formula, like we can see in what? In alkane. That of alkene is CnH2n. That of alkene And we are going to see that by the time we begin to study each of the homologous series, we'll now, in the introductory part of each of the homologous series, we usually talk about their general formula. Okay. Number 2, each member differs from a preceding member by methylene group, which is this, methylene group is this, or a mass of 14 gram, a mass of 14 gram. Okay, so each member differ from a preceding member by a methylene group. Let's use our alkane still, so that we can now see this definition at work, right? Let's still use our alkane in the explanation. So let's write maybe the first 4 members of the alkane. The first one is methane. The next one is what? Is ethane. The next one is what? Propane. And the 4th man there is what? Butane. Okay. What's the molecular formula of methane? CH4. Just from that general formula we explained previously. So this one is C2H6. This one is C3H8. And this one is C4H10. Okay. So let's see the difference between them. Between this and this, we say that a member will differ from the member after it, or even a member before it, by what? Methylene group, right? A member after it or a member before it. So after methane we have this. What's the difference between them in terms of number of hydrogen and number of what? Carbon. If you look at this, this has 2 carbon, this one 1 carbon. So what's the difference between these two? Now is going to be 1 carbon, right? 1 carbon difference, right? And then 6 hydrogen, 4 hydrogen. What's the difference now? 2 hydrogen atoms. So you see the difference between this and the member after it is what? CH2. That's the methylene group. Then if you look at ethane and the word propane, the difference in the number of carbons still remain 1 carbon. That's C, 1 carbon. And then the difference in the number of hydrogens still remain 2 hydrogen. Then here, the difference between this and this in terms of the number of carbon is still 1 carbon. And the difference between the hydrogen atoms is what? 2. Now somebody may be asking why we usually put this. In organic chemistry, carbon should have 4 bonds. That's why already we have 2 hydrogen, meaning 2 bonds. Because of these 2 hydrogen, then we need to put this to show extra 2 bonds that this carbon is supposed to have, making it what? 4. So you discover that in homologous series, a member differs from a successive member by what? Methylene group. So explaining this, our what? Our definition. Now we added here by methylene group or a mass of 14 gram. Let's quickly get the masses of all this. Let's get their masses. Let's get their masses. Now, what will be the mass of methane? Carbon is already 12. And we know that hydrogen is 1 times 4 atoms will give us 4. 4 plus 12 is 16. So the mass of methane is 16. Then the mass of this, 2 times this is already what? 24. 24 plus 6, when you multiply that, we'll have 30. What will be the mass of butane? 3 times this is already 36. 8 times 1 is 8. 8 plus 36 will give us what? 44. So we have 44. 30 for methane, for ethane, then 44 here. So 4 times this will give us what? Will give us 48, right? Yes. And 10 times 1 is what? 10. 48 plus 10 will give us what? 58. Now, what is the difference in terms of mass between them? If you check the difference between this and the member after it, 30 minus 16 will give me 14. 44 minus 30 will give me 14. 58 minus 44 will give me what? 14. So that's proving these characteristics of what homologous series. Okay, I know that is very much clear now. Okay, so each member differs from a preceding member. So let's add that preceding member by methylene group, preceding member by methylene group, and we have seen that differs from a preceding member by methylene group. So we have seen that, or by a mass of what, 14 grams. We have also seen that here. Okay, all right, so we move again. Number 3, they have the same functional group. They have the same functional group. They have the same functional group. So in homologous series, all the members in that series must have the same functional group. If you take alkanol, for example, if you take alkanol as a homologous series, you will notice that all the members here, they have the functional group, which is the hydroxy group. Take, for example, you have methanol. It contains this OH. You talk about ethanol. It contains this OH. You see it? Propanol, propan 1 or propan 2 or butanol, all of them, the functional group remains the same. So in a homologous series, all the members, they must have the same functional group. They must have the same functional group. We are going to talk about functional group in our next video as the next term used in organic chemistry. It's a very important term in organic chemistry. So, number 4. They undergo similar chemical reaction. So the members in a given homologous series will usually undergo similar chemical reaction. They will undergo similar chemical reaction. Yes, the members. So if you are considering a particular reaction in a given homologous series, let's take, for example, you talk about alkane. If methane will undergo the reaction, then ethane is expected to undergo that chemical reaction. That means if methane can react with chlorine, it means that ethane can react with chlorine, since it's in the same in the same family. Yeah, you see, it's a family business. It's a family business. So all of them are in the same family, so they will undergo the same the same reaction. That's why even in real life now they say, there is a way this family behave. Yeah, we understand. This person is from this family, because they have looked at how the person is acting. So they now know the person belongs to that family. So when you see alkane, when you see methane, when methane acts, ethane acts, they say they are from the same the same family. So members of the same homologous series, they will usually undergo similar chemical reaction. All right. They have a regular pattern or a regular gradation in their physical properties. So let's say they have a regular gradation in their physical properties. They have regular gradation. What do we mean by that? For example, if the boiling point increases as the number of carbon increases, it will be uniform. That's what we mean, regular gradation. If we look at alkane, as the number of carbon is increasing, the boiling point will also be doing increasing. So you will expect ethane to have a higher boiling point than methane, propane to have a higher boiling point than ethane, in that order. So they have a regular gradation in the what? In the physical what? The physical properties. So if we talk about increase in anything or decrease in anything, it will not increase, and at a particular point it will start decreasing, and then to start decreasing and then increase again, decrease again. No, they have a regular gradation in their what? In their physical properties. So if I have this, for example, methanol, ethanol, propanol, these are members of the alkanol world family. If we have any physical property that is increasing from here to here, it will continue to increase. It will not increase and decrease, or maybe decrease and increase. So if boiling point increases from methanol to propanol, it will increase from here to here to here. It will not increase from here to here and then decrease from here to here. That's what we mean by they have a regular gradation in their physical properties. All right, these are the 5 main characteristics of what? Of the homologous series. All right, I believe that you enjoy this video on homologous series. By now you know the meaning of homologous series, and you know the examples of homologous series, and now you also know the characteristics of homologous series. In our next video, we are going to take another basic term in organic chemistry, and that will be functional group. We're going to look at functional group. There are so many basic terms. After that, we start talking about hybridization. We also talk about isomerism. Make sure that you don't miss any of these videos. Like I used to say, if you want to really understand any topic, you must start it from the beginning. And that's why if you have not watched part 1, part 2, part 3 of this video, please look for those videos, watch them, so that you can flow easily with us as far as the concept of organic chemistry is concerned. All right, till I come your way next time, I'm still your lovely friend and brother, Engineer I Okechukwu. Keep living, keep winning, and also keep excelling in all that you do. Bye.